Good morning, students, and today we are going to continue with the lesson of atomic structure, that is our next lesson. And today we are going to study how the atoms were introduced. Now from the ancient times, the philosophers said that the universe is made up of tiny invisible particles, and there are tiny particles that we don't see, but everything is made out of that. So there was a Greek philosopher, his name was Democritus, and he said that there are tiny particles that make up the universe, and everything is made by these tiny particles. Those are invisible to our eyes, and they are also indivisible. So he called these particles as atoms. Atoms in Greek means indivisible, means they cannot be divided any further. You cannot make something else by cutting it or breaking it. So that was the term was given as atom. So there was also Indian philosopher named Maharishi Kanada. He called these atoms as anus. He called them as anu, and he said these anus are made up of subparticles, some subparticles. Those he called as parmanus. This was given by Maharishi Kanada. Now Dalton's theory came into light. Dalton gave his atomic theory, where he gave the postulates about which we have studied in the previous video. Now here John Dalton also gave the symbol system. So what he did was, for every atom of every element he gave a symbol. For example, elements like hydrogen, it was hydrogen. He gave this symbol as a circle and there was a dot in between. Then for nitrogen, he made a circle and there was a vertical line. For carbon, he made a circle and it was filled or it was shaded. For oxygen, he just made a circle. And so on. He gave the symbols to these elements. The atoms of the elements were represented by these symbols. Now it made very difficult for the scientists to remember the symbols as well as to form a chemical equation, because the equations were very important and they are the heart of the chemistry, and these were not being formed with these symbols. So it was in 1831 another scientist, J.J. Berzelius, what he did, he introduced the symbol system that we use now today. That was for hydrogen. He said instead of using this symbol, we can only use the initial letter, that was H. Now for the next, which was helium, he said because H is already given for hydrogen, we can take the first two letters, that is He. That was helium, and so on. The symbols were introduced. After this, the modern atomic concept came into light. Now Dalton's model could not explain why atoms of an element differ in their masses. That means every element is different, their atomic mass is different. Now he was not able to find that why. So the studies went on, and there was the introduction of the subatomic particles. That means the atom is not simply one thing, it is made up of subatomic particles. Those were electrons, protons and neutrons. Now these were discovered. These were discovered at different times by three different scientists. So the atom is not simply one thing, it is made up of subatomic particles. These are called as subatomic particles: electrons, protons and neutrons. So the electrons, the first one, these were found by J.J. Thomson. He found that these electrons have a negative charge, and their mass is about they have a mass of 1 by 1840 of hydrogen mass, okay, of the mass of the hydrogen. That means hydrogen mass, if it is 1, it will be divided by this much. That is the mass of an electron. It is very, very small. Now it came to protons. Protons were introduced, or they were found by Goldstein. This was another scientist, and he found that protons have a positive charge. They have a positive charge, and their mass was 1840, okay, 1840 times that of electron, okay. So this was found for protons. The third one was neutron. Neutron was found by Chadwick. Now Chadwick told that these neutrons are neither positive nor negative. So they were the neutral particles. It was found, and so they are called as neutrons because they don't have any charge. These are neutral particles. They also have the mass same as protons, okay, mass. They have the mass of protons. So this was the findings done for electrons, protons and neutrons. Then later on, the plum pudding model was introduced by J.J. Thomson. J.J. Thomson, he gave the plum pudding model. Plum pudding model, in which they considered the atom as a sphere. They thought that atom is a sphere, it is like a ball, and in that if we cut the ball, we find that there are positive and negative charge particles embedded in it. This was the plum pudding model. It's just like a cake, a cupcake, and you cut it from between. You find some fruits or nuts in between. It was just like that. They thought that this atom is some matter, it is made up of some matter, and if we cut the atom, it will be having positive and negative charge embedded in it. So this was the plum pudding model that was given by J.J. Thomson. Okay. Now, why is an atom electrically neutral? It is asked, okay, question. Why the atom is electrically neutral? That means either it is neither positive nor negative. When we consider an atom, it is neither positive neither negative, it is neutral. Why? This is because the number of protons is equal to number of electrons. Means as much as positive charge is there, it is equal to the negative charge, so they cancel each other, so the atom is neutral. So this was for today, and we'll continue with the Rutherford's experiment, Rutherford's gold foil experiment in the next class. Thank you.